Hello, this is Mr. Wynn with the video about operations with complex numbers. This is pretty important. So, complex numbers, well, y'all know they're real numbers like 5, -2.3, a fraction 1/4, or pi, but they're also imaginary numbers, and those are things that have I. So in the past, you've worked with real numbers only. For example, you've seen the problem x squared equals 25. So some number times itself is positive 25. Hopefully you know you can square root both sides. Square of x squared is x, square of 25 is 5. Now actually when you square it, you have plus or minus. But positive 5 times positive 5 is 25. Negative 5 times negative 5 is also 25. Then you have this problem. Some number times itself is negative 25. Well, positive times a positive is positive. A negative times a negative is still positive. So how does something times itself become negative? So we're stuck there. But our answer comes from using I. Alright, so I is called the imaginary unit. It's defined as I squared equals -1, a very important fact. Or if you square both sides, I is also equal to the square root of -1. So actually in the past, you've learned if you have square root of 18, you can break it down. You say square root of 18 is the same thing as square root of 2 times 9. You can break up square root to multiple square roots. So square root of 2 times 9 is the same thing as square root of 2 times square root of 9. Square root of 2's we don't know, but square root of 9 is 3. Then we can multiply 3 times square root of 2 to get 3 root 2. We have the same logic to do this. So square root of -25, we don't know that, but we can say that's square root of -1 times positive 25. We can break that up to 2 square roots. Square root of -1 times square root of 25. And we know that square root of -1 is just I, and square root of 25 is 5. So we know this is plus or minus 5i. So in the calculator, there actually is I on there. So let me show you where that is. In the calculator, I is actually second period. So I do parentheses, I do second, let me do 5 first. 5 second period squared, 5i times 5i is -25. If I do -5i squared, I still get -25. So now we know what the square root of -25 is. We'll try another one. So this one's the square root of -48. I can change that into the square root of -1 times the square root of 48. We know square root of -1 is I. And the square root of 48, let me do it like this. Hopefully you learned this tree branch method. So we know 48 is 4 times 12. 4 is 2 times 2. 12 is 2 times 6. 6 is 2 times 3. And hopefully you know to circle pairs. Pairs go out, non-pairs stay in. So outside, I'll go down here. We have this I, we have a 2, we have another 2, and this 3 stays inside the square root. All the things outside multiply together. So our final answer here will be 2 times 2 is 4, 4i square root 3. And that's the answer. Alright, going forward, I has this weird rule, and that is I can never have an exponent. So we have to know what I to the first, second, third, and fourth is, and then it repeats. So you should memorize these or know how to create it. So when you have I to the first power, it's okay to have invisible 1, so we don't actually do anything. But you have to know I squared equals -1. That's the most important fact. If you see I cubed, use our exponent rules. I cubed is the same as I squared times I. Well, we know I squared equals -1. So I'm going to replace I squared -1. So -1 times I is just -I. So I cubed always turns into -I. Then for the last one, I to the 4th power, well, I to the 4th is the same as I squared times I squared. We know this is -1, this is -1. So -1 times -1 is +1. Now, if you don't know, you could actually use a calculator to help you. The calculator knows all these. So it knows I squared is -1. It knows I to the 3rd power is -I. It knows I to the 4th power is +1. But you don't always get the calculator, so make sure you do it. Then it repeats the cycle. So I to the 5th power is really just I to the 4th times I. Well, we know I to the 4th is 1. 1 times I is just I. I to the 6th is really just I to the 4th times I squared. I to the 4th is 1. I squared is -1. So 1 times -1 is -1. I to the 7th is I to the 4th times I cubed. So we know that's 1. I cubed, we know earlier, is -I. 1 times -I is just -I. And I to the 8th is just I to the 4th times I to the 4th. Because exponent rule says the same base as I at the exponents. 4 plus 4 is 8. But that's 1 times 1, that's just 1. It just keeps going. The shortcut here is you might get a big number like this. You should just subtract 4 until you get to a number between 1 to 4. So I subtract, say, 4 times 5 is like 20. 26 minus 20 is 6. I want to subtract 4 again, so 6 minus 4 is 2. I squared, we know, I squared is negative 1. Alright, then we have the next slide. So, imaginary numbers can go with real numbers. We usually have the form a plus bi, where a and b are numbers and I is imaginary. So we have what we call the real part a and the imaginary part bi, because I is imaginary, it goes with b. When we have both parts together, we call that a complex number. So look at this right here. This thing is my a is 5, b is negative 2, and that's I. It's complex because it's 5 minus 2i. And in order, we always want the real part first and then the I part second. Alright, and the good news is all the math stuff you learned still works with imaginaries. So add, subtract, multiply, divide, distribute, all that the same with I. Alright, just make sure you fix any i's with exponents in your answer, because I can never have an exponent. Alright, so this will be basically the same thing as operations with polynomials. Do you know how to add, subtract, multiply, parentheses? So the slide should look similar. So when adding and subtracting complex numbers, determine the parentheses matters. Parentheses only matter if there's an exponent or a number or sign in front of it to distribute. So does the first parentheses matter? Answer is no. This stays the same. Does the second parentheses matter? Yes. I have to distribute this to negative 2. So I get negative 10 minus 6i. I combine terms, but remember I has to go last. I want the real part first. So 4 minus 10 gives me negative 6. Then negative 2i minus 6i makes negative 8i. And that's good. That's our answer. The real part is negative 6. The imaginary part is negative 8i. Good thing is calculator can do this, although you won't get it for the test for this part. I can write parentheses 4 minus 2 seconds I minus 2 parentheses 5 plus 3 second I, and it tells me the answer is negative 6 minus 8i. Alright, so adding and subtracting the same thing. Just again, determine the parentheses matters, distribute if you have to, then combine like terms. Alright, the real one's multiplying. So again, like multiplying complex numbers, you'll distribute every term in the first parentheses to every term in the second parentheses. We still use our FOIL technique. Just be very careful, or double distribute. Just be very careful to fix I when there's an exponent, because we will have that here. So I'm going to do this 3 times both of these. 3 times 6 is 18. 3 times 2i is positive 6i. Then I'm going to do this one. Negative 7i times positive 6 is negative 42i. Negative 7i times positive 2i, that's negative 14i squared. Alright, now I have an exponent. So I actually want to fix I right away. So I'm going to do this. I'm going to leave everything alone. But we know I squared is negative 1. Alright, so if I fix that, this is really 18 plus 6i minus 42i. And negative 14 times negative 1 is positive 14. Basically, I squared always changes the sign of the number it's on. If I combine like terms now, then I'll be done. So real part first, 18 plus 14, that's 32. Then positive 6i minus 42i, it's negative 36i. That's my answer. Again, there's no exponents for I in your final answer. A lot of kids forget to change I squared negative 1 and they get this wrong. Alright, again, calculator smart, it knows how to do this. It's 3 minus 7i, so second period. Then 6 plus 2 second period. It says it's 32 minus 36i, like I have it. Alright, so all that's the same. Just make sure you change I squared to negative 1 when you see it. Alright, the last part is division. One other rule about I, besides no exponents, is I cannot be in the denominator. If you see it in the denominator, you have to rationalize the denominator by multiplying by the conjugate, or in this case, really this complex conjugate. And the complex conjugate is really just the bottom, the denominator, but just change the sign in the middle. So a plus bi has the conjugate a minus bi. Keep everything the same, just change the sign in the middle. So there's the formula, although I'll do a problem and make it look a lot nicer. This also applies to root signs, radicals. They can't be in the denominator either, so you might have seen this before, but rationalizing the denominator is the same thing. You just multiply by the conjugate. So whatever's on bottom, you just change the sign in the middle, but keep it the same. This does involve foiling and distributing, but you'll see that the I on the bottom and the square root on the bottom disappears. So let me do a problem. So again, you have to FOIL. So this first one, I have I on bottom, and also this calculator cannot do this. The calculator cannot do division. I'm going to multiply the conjugate. The conjugate will be the bottom, but with the sign changed. So instead of 4 minus I, it'll be 4 plus I on top and bottom. Now if it helps, you can put parentheses here, but we're going to have to FOIL or distribute. So I'm going to do the top. I'm going to distribute 3 to both of these. I get 12 plus 3i. On the bottom, I'm going to distribute or FOIL. 4 times 4 is 16. 4 times positive I is positive 4i. Then this inside, negative I times 4 is negative 4i. Then negative I times positive I is negative I squared. Alright, when you, let's see, I'll leave the top alone. For the bottom, I need to fix or combine terms. Positive 4i minus 4i cancels out. When you have this middle sign different, it always cancels out the middle terms. That's good. So really I have 16 minus I squared. But I can't have 16 minus I squared. Remember, it's minus I squared is negative 1. So if I fix that, when you subtract a negative, that's really adding. So this is going to be 12 plus 3i over 16 plus 1 is 17. That's my final answer. There is no I on bottom anymore. So we rationalize the denominator. Same for this other problem. Can't have I on bottom. I multiply the conjugate. The conjugate, again, is the exact same thing, but change the sign in the middle. So minus. Alright, now for this one, I have to FOIL twice on top and bottom, but that's okay. So I'm going to distribute. So let me do like this. 3 times 2 is 6. 3 times negative 3i is negative 9i. I times 2 is positive 2i. I times negative 3i is negative 3i squared. On the bottom, 2 times 2 is 4. 2 times negative 3i is negative 6i. 3i times 2 is positive 6i. And positive 3i times negative 3i is negative 9i squared. Alright, remember when we combine the bottoms, this negative 6i, positive 6i cancels out because that always happens when you change the sign in the middle and you FOIL. This is 6 minus, I'll combine this now, negative 9 plus 2 is negative 7i. 3i, negative 3i squared, I'm going to change it to negative 3 times negative 1. On the bottom, it's 4 minus 9, I squared changes to negative 1. So we've got to fix those real fast. This is really 6 minus 7i plus 3. And this is really 4 plus 9. I combine. So on top, 6 plus 3 is 9 minus 7i. On bottom, 4 plus 9 is 13. And that is my final answer. Again, there's no I on bottom. I can be on top, that's okay. But we rationalize it because I is no longer there. As for the video, hope you enjoyed it. Make sure you ask any questions in class. See you soon. Bye.